You start recording. So, yeah, what we're going to do is we're going to go through these questions that are on this thing. So if you do have the questions in front of you, or your booklet, or if you did actually do the test and now you want to just use it as time to do some marking, then awesome, that's really cool. But yeah, what we've been doing in these past few sessions is before we go ahead and solve one of the questions, I first of all start off by trying to dissect the question and try to see, seeing that this question's worth 2 marks, I want us to look at it and think, where are those 2 marks going to be given? Because that's a skill that you guys need to know for your HSC. When you see a question, you see 2 marks, you should be hitting those beats like I've talked about in the past. So, here, we want to show that the derivative of blah 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 equals that. Alright? So, looking at that, where do we think our 2 marks are going to be? Differentiating. Yeah, that's basically it, and then getting that. Because when we differentiate it, we're going to differentiate it, and we'll talk about how we're going to differentiate that. And then afterwards, we're going to get something which kind of doesn't look like that. But then we're going to see that we're going to need to factorize something at the end, and that's going to be the other mark, actually making it equal that. So this is one of those questions where just by differentiating using product rule, you could leave it in that form, but then the question would be like, you need to show it in this factorized form. So let's go through this. So we have this function, y equals x squared e2x. So how are we going to differentiate that? Which was product rule, yeah. So we're going to say that u equals x squared, so u dash equals 2x, v equals e2x, so v dash equals 2e2x, yeah. I'm not just going to go through setting up to certain whole thing. I will be asking you questions as we go through. So remember to differentiate that, we differentiate the power, bring that out the front, and then we got that. So now, from that we can use our product rules. We have y dash equals, so remember we do that times that, so 2x e2x plus 2x squared e2x.
So is it a thing that you put e or apply, or you just trying to consist of x?
Oh well, I mean it doesn't really matter honestly, but I generally, I will put like any pronumerals, coefficients at the start first, obviously. Then maybe any x's and then e's with powers at the end if you want to do it that way. Yeah. It's not right or wrong either way, but yeah, generally there are conventions that we follow. Alright. So then we have that. So that's our 1 mark because we've done the differentiation part, but that's not what the question is asking us to do. The question wants us to show it in a particular way. And then so you look at it, well, how do I get from there? Well, we can just take out a common factor. Okay? So what's the common factor here? Yep. We have 2's, we have x's, and we have e to the power of 2x, leaving us with just 1 plus x inside the brackets, which is what we wanted. Now with product rule, I know some people do it the other way around. So rather than doing u dash v plus v dash u, you did the other way around. So u v dash plus v u dash. So you would have had the x squared there instead. And when you factorise it, you would have had x plus 1 in the brackets, which is totally fine. 1 plus x is the same as x plus 1. So if you did do that, and you just left it as x plus 1, you could have then on the next line just written it as 1 plus x, because they are the same. Or just leave it just left it as x plus 1 with a hashtag next to it. I would have known it, and the HSC would have marker would have known that x plus 1 is the same as 1 plus x. So, our 2 marks basically come from doing the product rule and then doing the factorization at the end. Okay? So, question 2. We have considered this function blah blah blah. Find the stationary point, and the fact that saying stationary point is kind of suggested, and determine its nature. And then part B is to prove that there are no points of inflection in the curve. Alright? So, starting off with part A, we have 3 marks for it this time. So again, before we jump into the question, We're thinking about the beats that we want to hit. So where are our 3 marks do you reckon we're going to be? Well, yeah, for finding the point, that would be one of them. Differentiating, yep. By differentiating again and then subbing in there. Yeah, so that's basically it. Differentiating would be 1 mark. Finding the y value would be another mark. Finding the nature would be another mark. There's your 3 marks. Alright, so generally when you've got questions that ask you to find stationary points in their nature, they're generally going to be 3 marks, and it's going to be those 3 things every single time. Differentiate, y value, nature. Okay? So, let's go through that. So we have, so f dash, what's the derivative of bx?
Yeah.
Bx, and what's the derivative of x? 1. So there we go. So what we want to do to find stationary points, we make that equal 0. So therefore we have 0 equals e to the power of x minus 1. So we have 1 equals e to the power of x. So what does x equal? 0. Because anything to the power of 0 is 1. Okay, so what we could do if we really wanted to is if we're trying to solve this exponential equation, what's kind of like an easy way of solving exponential equations? Yeah, we could change it into logarithmic form. So we could say log base e, which is we know is ln, log base e1 equals x, and then you just do ln1 is x equals 0. I mean, what you're asking yourself here, this is e. E is just a number, right? If I make it to the power of x, it equals 1. Any number to the power of 0 equals 1. So it could be pi to the power of x, and still be 0. Okay? So there's that. So there's our 1 mark. Well, sorry, our first mark was the actual differentiating. The next mark, or actually, yeah, because we need to find the point. So maybe you could say maybe that mark is down here, perhaps. Okay. And in fact, according to my marking criteria, because remember this is just the assessment task from 2 years ago. So according to my marking criteria, we've got 1 mark to find the x value, 1 mark to find the y value, 1 mark to find the nature. Okay. So we've got that. So now, what we also need to do to find the nature is we want to find f dash dash x. Well, yeah, we'll get to that in a second. Remember, I want to find this nature as well. So I generally do it all in one go.
How would that impact the y?
It won't. But I might as well do it all in one line. So I found f dash x. I might as well find f dash dash x as well. So the derivative of that, well, it's just still e to the power of x, and then negative 1 just goes away. Cool? So now I have that, and then so now, if x equals 0, y equals, well, we're just going to sub 0 back into that original thing. So it'll be e to the power of 0, which is 1, minus 0 is 1. And then when I sub it into y dash dash or f dash dash, it'll be e to the power of 0.
1.
Fine. No, we don't make, no, that's for the point of reflection, which is what we're going to be doing in part B. So when we're trying to find the natures, we're subbing in this. So we do e to the power of 0, it equals 1. So because it's positive, what does that mean about the point? It's concave up, so it's a local min. Alright? So therefore, we have 0, 1, it's a local min.
So is nature min or max?
Or point of horizontal reflection.
Yeah, because like.
So you find that by subbing that. So that point 0, when you sub it into the second derivative, if it's positive, it's a local min. If it's negative, it's a local max. If it's 0, that means it could look like that or that.
There's another word instead of local min. What did I say?
Absolute min.
No, it's like another word that you can put here instead. I think I don't know what it's called, but it's always nature.
concavity.
What do you
It wouldn't
say
be. You could say it's concave. You could say it's concave up, but we know
They wouldn't
concave
ask
up. No, that's not right.
So whenever you say nature, it means local.
It means either local min, local max, or point of horizontal inflection. It's one of those three. Saying that it's concave up is not correct.
So what needs to be here for it to be a inflection?
That's what we're going to do in part B.
Okay.
So in part B, we're trying to show. In fact, we're not asking to find the points of inflection. We're showing that there are no points of inflection. So to find a point of inflection, we need to find f dash dash x, which we already found as e to the power of x. And so to find points of inflection, we need to make that equal 0. We don't make x equal 0. We're trying to find how can we make that 0. Okay? So therefore, we are solving the equation e to the power of x equals 0. And then so, that you literally just say that. You can say e to the power of x and not, it's like cannot. You can just say there are no solutions, or it's like no solutions. Yeah. Yep, you can say that, like x can't equal 0. But I mean, you should explain why that's relevant. So you should say, like, me saying that is me saying, this is me, I know how to find a point of inflection, I've got to make that equal 0, but there are no solutions, therefore no points of inflection. Which is fine, it's only 1 mark, so it was only supposed to be like a little bit of working.
Okay, so you know how when you say x equals, if x equals that, y equals that, y equals that?
Yeah.
So, for example, okay, so see how sometimes they don't give part B for a question, sometimes it's like a trick where it's not local min or local maximum, it's supposed to know that it's like concavity, whatever, inflection. What would be negative or positive? And what if they're all 0?
If x equals 0 and y equals 0, that means that stationary point is.
Maybe it's not like that. Maybe it's just.
Yeah. So I'll do it. Let me do an example in a second. I'll show you exactly. If that all happens to be 0, that means first of all your stationary point at 0, 0, so the origin. And if you find y dash dash to be 0, that means it's a point of horizontal inflection. That means it's either going like that, so it's going up, then flat, then still up, or it's going down, then flat, then still down. Okay? So the classic example of that, and I might just jump to the end of these slides, say I had fx equals x cubed. Yeah. So to find a point of the stationary point first of all, find f dash x, and that equals 3x squared. And I might as well just find the second derivative because we're going to use that in a second. So r needs to be 6x. Cool. So to make that, I'm going to speed it up. To make that equal 0, obviously x needs to equal 0. Okay. So if x equals 0, we'll find that y equals 0. So just subbing into that, 0 cubed is still 0. And y dash dash with 6 times x is 0. Okay. So therefore, we have 0, 0 is a point of horizontal inflection. So what that means, if I were to sketch y equals x cubed, then you should probably be able to just do that in your head anyway. It looks something like that. So we know it looks like a point of horizontal inflection when y dash dash equals 0 at that x value. Okay. Cool. Essentially, a point of horizontal inflection happens when a point is a stationary point and a point of inflection at the same time. Kind of combines. Alright. So yeah, that's that. Yeah, so does everyone kind of make sense? yeah, we said that e to the power of x can't equal 0. I mean, the other way that you could have done that, if you're not sure, if you just weren't sure of that, or you just need to double check yourself, we could also again just do ln 0 equals x. And when you put ln 0 into your calculator, it will give you a math error. Because I just rewrite that in exponential terms. Alright, just do ln 0 in your calculator. Cool. So going into question 3. So we want to find the exact area bound with the curve blah blah blah, the x-axis and the lines x equals 3, 0, and 3. So if I were to do a really quick sketch of that, it will kind of look like that. And we want to do it between.
He says no.
There's no sketch. No. That's not bad.
Would there be?
Yes, it would be. If it was in your assessment task, what other would be? Alright, unless in that original question I asked you to sketch it yourself. But that would be like there'll be marks on it. But yeah, so basically that's what the curve basically looks like. Okay? And we want to find the exact area bound between the curve, blah blah blah, the x-axis. The reason why they need to do that is if I didn't bound it between the x-axis, it would just keep going on forever. Right? But also the x-axis tells me I want to integrate with respect to x, so it's going to be dx. The line x equals 0 and x equals 3. And the other thing is you may assume that there are no x-intercepts on the curve. The reason that's there is you might remember we did some questions last year where, like, say the curve did that, and I needed to integrate between 0 and 3. So what you would need to do is find that x-intercept at, like, say, 2, for instance. We need to integrate between 0 and 2, and then between 2 and 3, and then add them together. Yeah. So, the reason why I've added that little extra bit there is so you know you don't need to look for x-intercepts. You just assume that. I mean, the other way that you know that is, like we just said, e can never equal 0. So if you didn't even need to be told that, you can just say that it's we're trying to find the area bound between curves. So basically our area is just going to be between 3 and 0 for e 2x dx. Does that kind of answer your question from earlier? Yeah. Alright, cool. And then so now what we want to do is we're going to integrate this. So when we integrate it, remember, or are we allowed to integrate this? Yeah, because that power is linear. If that was like 2x squared or something, we no longer can. Okay, so remember integration has very strict rules, but here we're fine. So we integrate, so we differentiate what's inside, and we divide by that derivative rather than multiply the derivative. So 4 divided by 2 is 2. So we have 2 e 2x 0. Yep. And then, of course, now we just sub things in. So this becomes, well, 2e 2e to the power of 6 minus, well, e to the power of 0 is 1, so it's just minus 2. Yeah, oh, I forgot to go through the question and like find the beats of the question, but it's worth 2 marks. Essentially, like, what do we think the 2 marks are going to be for? Integrating in the subbing. So basically, I mean, 2 marks for 2 lines, very nice. Okay. I mean, I guess 3 lines because at no point in the question did it say this, you just needed to interpret it. So maybe you could say there's 1 mark for setting that up, but actually, maybe not. Maybe, well, I'd say 1 mark for, in fact, looking at my marking criteria, 1 mark for integrating, 1 mark to substitute to find the area. Okay, so 1 mark here, 1 mark here. Cool. Question 4. So solve the following equations, leaving your answers to 2 decimal places when necessary. So we have ln x equals p. So any suggestions on how we're going to solve this one? I might just work to the side here. Not the logarithmic form, the exponential form. Yeah. So what we're going to do here, if you remember that's base E, so we're going to do, I'll write in red here. So remember base becomes the base, that subject becomes the power. So x is e to the power e, which looks weird. Okay, remember the whole, say I had a to the power of x equals b. When I put that into logarithmic form, it will be log a b equal x. So I think that's just logarithmic form change. So here we have log base e x equals e. So a to the power of x equals e. Yeah, basically, remember the whole point of logarithms is for us to write exponentials in a different form, which makes it easier to solve. So, solving that, what we did here is we did the opposite. Solving that in logarithmic form is incredibly hard, but if I change it into, because we're trying to find x, and the way that you solve equations is get x as the subject. So we're rewriting it so x is the subject, so e to the power of e, which is like, so therefore x equals 15.15. Because the question did say it's 2 decimal places now. So, cool. Next is we have log 5x equals 7. I don't think there's another way. Okay, so 5x. How can we split that up? Remember the multiplication rule with logarithms? How can we split that into 2 different logarithms? Yeah. So we're going to do log 5 plus log 5x equals 7. Does that make sense? Now what does log 5 equal? 1. Yeah, remember log base anything of that same number is 1. So we have 1 plus log 5x equals 7. We have log 5x equals 6. We're trying to find the value of x. And now we've got, again, we have a logarithmic equation which is hard to solve by itself. So what should I do? Yeah, change it into exponential form again. So here I'll have 5 to the power of 6 equals x. 7 minus 1. Okay. So 1, 5, 6, 5. There you go. No. 5 to the power of 6 is exactly 15,600. What you don't know that? Oh, come on. So, and then lastly, we have this one. So, suggestions how I'd solve this. Put it in log form. So, generally, if we have ugly logarithmic equations, we want to change an exponential. Same thing here. If I have an exponential thing, I want to change it into log form. So, I'm going to just do C again, do a bit more space. So, remember, log, the base becomes the base, subject becomes the thing that's being logged, we have x minus 4. And then, so, obviously I want x by itself, so what do I need to do? Yeah, plus 4 to move that 4 to the other side. So x equals log base log to 11 plus 4. Now, obviously, like I said, we don't have a button for log base 2 in our calculator. So how can I find the value of log to 11? Change base. Alright, so remember, we can rewrite log to 11 as lim 11 over lim 2, which is the button that we have. Why did I do that? Because there's no button in our calculator that can do log base 2. Alright? I'm trying to find the exact number. I mean, if the question didn't need me to find two decimal places or whatever, I could have left it as that. But it does want me to do it, and my calculator cannot do log base 2. So I'm going to have to do change of base. And then once you put that into your calculator, you get 7.46. So 2 decimal places. Alright? So this question was all about knowing how to change between exponential form, logarithmic form, moving things around, all that kind of stuff. It also has a few identities in there, like knowing that log by 5 is 1, or log anything is 1. Any questions on that before I move on? Question 5. Basically the same question. How would I do this? Change base again. We have ln 7 over ln 3. Put that in our calculator. And this is to 3 sig figs to 1.77. Very basic.
That's the only one I knew.
I reckon.
Like I knew
that's the point of this.
completely. The rest I got
You were kind of like, I'm not sure, but this one I've smashed it. Yeah. Alright. But making sure that we're reading the question carefully. It's not 3 decimal places, it's 3 sig figs. Make sure you do that. So find the gradient of the tangent, blah blah blah, at the point whose coordinate is 0. So again, before we jump right into this, let's go ahead and decipher the 2 marks. What do we think the 2 marks are going to be? Yeah. Alright, so gradient of tangent. Gradient of tangent is found by differentiating. So you know right away there's probably going to be a mark of differentiating. And then at the point whose coordinate is 0, there's another mark. Okay, there's your 2 b's. So you should look at this question like, I'm going to differentiate that. I'm going to make x equal 0. So let's do that. Except differentiating that is going to be a bit of a pain in the butt. We could kind of do like some weird quotient rule inside of the chain rule kind of thing, but it's going to be a bit ugly. Alternatively, how can I write that in 2 different logarithmic expressions? Remember division, what do you do to split it? Minus. So here we can have y equals ln x squared minus 9 minus ln x plus 1. Because from there, differentiating that isn't going to be too difficult. Remember to differentiate logarithmic functions. You differentiate the inside. Wherever the derivative is goes on the top, and the original goes on the bottom. So what's the derivative of what's inside?
2.
Yep. So this would be 2x over x squared minus 9. And here this would be 1 over x plus 1. What we could, like I said, what we could have also done in the original is, if it was the same thing, you could differentiate what's inside, put that on the top, and put the original on the bottom. But just differentiating what's inside would be a bit of a pain because it involves quotient. Okay, it's doable, and then you would have got something. So there's one mark for differentiating, and then the other mark is just making x equal 0. So let's just do that. If x equals 0, y dash equals, well, that's just going to turn into 0 quite quickly because I mean we're doing 2 times 0, 0 divided by anything. So we just go to 0 minus 1 because if I make x equal 0, I've got 1 over 1. So therefore the gradient equals negative 1.
So you know how you said when you differentiate a whatever, do that. What was it? We differentiate what?
A ln. You differentiate a logarithmic function, basically. You differentiate what's inside, and you put that in the numerator, and then you keep what was inside and make that the denominator. That is in the formula sheet. That's cool. But the on the formula sheet, it looks like this. It looks something like I think it's like y equals min fx, then dy dx, or it's going to say y dash equals f dash x over fx. Yeah, sure. So basically, when you have ln, and to be clear, that's only if it's ln. If it was log-based anything else, you can't do it, right? You'll just need to do change of base. And then, so whatever function you have inside, you differentiate it, you chuck down the numerator, and the original in the denominator.
Is there any other differentiation for this topic?
Well, besides
other than the main ones. Yeah, other than that.
Okay, oh, that's it, no.
That's it.
Other than, so,
the base.
y equals e to the power of fx, y dash equals f dash x, e fx. Other than that, no. Oh, and change of base is also on there. No, it's got nothing to do with differentiation. It's log a b equals ln b.
Oh, yeah.
Yeah. Pretty sure those are the only correct things to go through. Can I go to the next page? Cool. And then last one on this. It is a bit slightly trickier. So the region bounded by, I'm not sure if that's proper English, maybe it's supposed to be I think it's bounded, but in the HSC it's bounded. So I'm like, okay, I'm just going to go for HSC language. So the region bounded by the curve y equals blah blah blah, and the x-axis between 0 and 2 is rotated about the x-axis to form solo find the exact lines. Alright, so it's being rotated around the x-axis, meaning I need to find not y, I need to find not x. Remember, to find the volume, I need to do v equals pi y squared dx. Alright, so looking at these, like, what? I need to differentiate that, that's going to integrate that, that's going to suck. Not really, because when you square it, this square root is going to go away. Alright? So we're going to have y squared equals 2x over x squared plus 1. Oh, sorry, before I do anything. 3 marks. What do you think we need to do? Is hit that one. Okay, so the first thing we need to do is find what y squared was. The next thing was integrate it. The third thing was sub it in, find the volume, all that kind of stuff. So now that we have that, so we now have, therefore, the volume is pi, and it's between what two values? 2 and 0. 2x over x squared plus 1 dx. Now, how am I going to integrate that? 1? Yeah. Yeah, it's ln the bottom. Do I need to make any changes to it? No. Because remember, if we find, like, whenever we have on the bottom, we just start that whole sentence. If the derivative of the bottom is equal to the numerator, it's just going to be ln that. So remember, whenever you're integrating something with just a big fraction, look for that straight away. So differentiate the bottom, is 2x. Oh, look, the top's also 2x. So that means we straight away can say it's just pi ln x squared plus 1 between 2 and 0. Yeah, so that's another mark. Integrating. And then lastly, so now we'll just sub these in. So we have pi times, well, when we sub in 2, so 2 squared is 4 plus 1, so we've got 5. and then we start in 0, so 0 squared plus 1, so minus 1. Ln 1 just equals 0. So this is just pi ln 5.
If we put that in ln 1, will it equal for us?
Yeah, ln 1 equals 0.
It'll come up there.
So, I mean, even if you like expanded this, you did. I mean, that's technically right. But then, you know, it's just a matter of dividing 0. Remember units cubes because we are finding a volume.
Okay, so Sarah, you said that just to look at the bottom if you differentiate and look at the top. So what if it's not? Like what if it wouldn't?
So that's when we have to do. Remember those goals and how it talks about finding goals.
So you timed it, right?
Exactly. So like, say I had another question. Say it was exactly that question, except rather than me having 2x on the top. So what was it? It was between 2 and 0. On the bottom it was x squared plus 1, but on the top it was just x. It was just x. Okay. Say it was that. So what we would do is we would want to multiply it by a special form of 1. Like, what's the derivative of the bottom? So that means I want to make the top 2x. Remember I talked about the goal being 2x. So what number can I multiply the top by to get 2x? 2. So what I'm going to do is I've got pi still sitting at the front, 0. I'm going to multiply by 2 over 2. So I don't want to change anything. I'm going to times it by x squared plus 1 dx. And then, so the whole idea is, I want to multiply that 2 over, but I don't want to pick that 2 over.
Okay, so.
And then now I'm allowed to take that half out. So I would have.
So you can't just put 2 over 1 times 0 over. Does it have to be the same number?
So just give me a second. Sorry?
So I tell you put 2 over 2 inside. I can't do 2 over 1. Like I can't just.
No, because you can't just change the top. It's like, I don't want it to be f, I want it to be 2s. I'm just going to do that.
So
right?
You have to, it needs to be the same number.
Oh yeah, I need to
3
account.
over 3
Exactly. I need to, like, so if I'm going to times the top by 2, I need to times the bottom by 2. Alright? And then what I'm allowed to do if I'm multiplying by just a number, I'm allowed to just take that out. Alright? So now, this is something I can integrate. This is what we just did a second ago. But for me to do that, I first of all needed to manipulate that numerator to be the derivative of the numerator. Okay? So yeah, whatever you do, like this is kind of like the counterbalance, I guess you could think. That's 1 times by 2 times by 2.
Okay, so you times it, you
Yeah, I mean, if I wanted, if instead, say for instance,
once you did the bottom here, you change the bottom to the top.
Yeah. Say for instance, I had, rather than that, say I had 4x on the top. Right? This time the goal is still x squared, 2x. So this time I want to make that, I can either make that 4 to be 2x, or I can times the bottom by 2 instead. So I could times by 2 over 2, except rather than take the 2 over the top, I can take the 2 on the bottom, because then I'll have 2x squared plus 2. And then when you differentiate that, there'll be 4x. You now solve the problem. Or, if I wanted to be really fancy, if I'm just like, no, I want the top to be, I want to change the top, I don't want to change the bottom, we could times it by, and this is where you might remember it got a bit ugly, I can times by half over half. And then what I'll do, well, half of 4x is 2x, and then when I take out 1 over half, it comes to, yeah. So that can go. So to answer your question, yes, you can divide, but you have to divide by multiplying by a fraction. Yeah. And I believe that's it, isn't it? There's no other questions, right? Alright, cool. In this last, I mean, do you guys have any other questions? Miscellaneous questions you just want to ask now? About chapter 4 or 5?
They don't. Do you guys? Okay, so if you guys have, yeah, go.
Okay.
Mine was going to take forever, so you go.
Sure. I think they got the textbooks here. So are you trying to find the question? Yeah. Okay. Cool.
Oh no, I know.
Okay. What question is it? Exercise what? 5, 5, 6, 8. Five, 5, 6, 8. Okay. So this is exercise 5.5, 6A. So what we have here is we want to find the length of the chord and then all the other things. Qualify an angle subtended at a, oh, okay. So what we have going on here is, so subtended by an angle of pi of 6, what's that in degrees? 30. So let's just draw it like that. And then we want to find the length of that chord there. So I'm going to just put it in red because that's what we're trying to find. What we're also told is this is pi of 6. This is 5. That's also obviously 5. So essentially we have a non-right angle triangle. How do you find sides of non-right angle triangles? Going back to year 11. That would be area. We can use sine rule or cosine rule. Because we're trying to find the side. So we're trying to find, like, let's call this x. Okay? So we could use cosine rule, or we could actually use sine rule, but I'm just going to use cosine rule. Okay. So we'll have to do x squared equals a squared, so 5 squared plus 5 squared minus 2ab, so there'd be minus 50 cos pi 6. So in a triangle in which we have that angle, we call that A, we call that B, we call that C. That's C. C squared equals A squared plus B squared minus 2AB plus C. That isn't the formula sheet. Yeah. You probably haven't seen this since like about this time last year. But that was at the end of chapter 5 or whatever trigonometry was. It's cosine rule. Yep. How would what? Okay, so let's build it that way. So that's when I see a non-right angle triangle, I immediately jump to sine or cosine rule. But if you don't see that, let's kind of zoom in on that triangle. So what you're suggesting is we have this. We know that that's 5, and we know that this is 30 degrees. So really, this is 15 degrees. Let's just talk about degrees from now on. All right. So we have, and this is a right angle triangle. What you're actually kind of doing there, though, is you're assuming something that you learn in extension maths and circle geometry. So you're assuming a radius is perpendicular to the chord, which it is, and you are allowed to do that in junior. But it is something you're kind of making a jump on here. But anyway, let's continue. So here, I mean, at this point, I can rub that bottom bit out, and I'm trying to find x. Okay. So, did you change it to degrees? No, that would be it. Alright, so here we have sine 15 degrees equals x over 5. So x equals sine 5 times 15 degrees. And then once you've got that, you have the times of that 2, but again, degrees. Or just do pi 12. You want to keep it radians. you would have done so when you did circle geometry. So it's an assumption because you don't need to say, you don't need to prove, you don't need to write a little theorem next to it. Radius is perpendicular to chord. Alright? But it is, I mean, it kind of, when you look at it, it kind of seems obvious that yeah, you can split it in half and that is 90 degrees. Because it is, yeah. It's like the very first lesson of circle geometry in year 11, and that's like the first topic you do in year 11 extension, so it's super advanced. Yeah. Do you need me to go through B and C or is it fine? Yeah, alright, cool. So it seems like it's just a matter of you change your calculator. Any other questions? It sounds like you have a few.
What was that thing again? Minus plus?
Okay, so that ASTC. So when you're looking at the first quadrant, obviously it's just theta. Alright? Are you talking about like trying to find the key?
Yeah.
So in S, what you're trying to do is, if you know you're in the second quadrant, you're doing 180 degrees minus the key equals theta. So if you're like talking, what I mean by that is it's 120 degrees, right? 180 minus what equals 120. Maybe, you know what, yeah, because you would read, okay, I explained it in two different ways. I'm just going to do it 180 minus theta.
Yeah, that's okay.
And then in T, I'm just going to do theta minus 180. And then...
So is this 180 plus theta?
No. So because you're thinking... Because if it was like 240 degrees, you're thinking of 180 plus what? So maybe it helps you like both ways. So in this one, you're thinking 180 plus the key equals theta. So that means the key is 180 minus 4. So theta minus 180. Yeah. Right?
So it's not
Yes. And then here, it is 260. And this is obviously just theta. So yeah, those are the ways that you find the key. And then obviously if it's below or above 0 and 360, you can just add or subtract 360. So say you had 500 degrees, 500 minus 360 is 240, and then you just go from there to 240, 180, 60. Next.
You guys do it. Is there any other like key questions or like cheat sheets that even if it's in the sheet, it's like very or not like kind of configuration. Very DY. So what's the
That it'll be dy if you're rotating around the y-axis. Yep. So if you've got a question that's rotating around the x-axis, you need to find y squared. If you're rotating around the y-axis, you need to find x squared. So let's say, it depends on the question. Say, I'm rotating the function y equals x squared. Okay? That's actually a really easy one. So I might not choose that one because I've already got x squared and it's y. But so the idea is, if I wanted to rotate around, this might help actually. If I wanted to rotate around x-axis, if I want to rotate around the x-axis, I would need to find what y squared is. So it would be volume would equal that y squared, which would be x to the power of 4 dx. Dx is the key thing. If it's around the x-axis, it's dx. I need x's in there. Yeah. Alright. If I want to rotate around the y-axis, that means I want to find x squared, and I'm going to be doing dy. And we already have x squared, so in this case, it would be b y y dy. These integrate the same. So y is x squared. That means y squared equals x squared squared. So if I were to Desmos this, maybe Desmosing could make this a bit simpler. People watching this video are going to be thinking, oh wow, it got really loud all of a sudden. I just uploaded them onto Edmodo.
Okay. So no? Okay.
So here's our x squared. If I rotate it around the y-axis, you can kind of think it will be kind of like a bullet kind of shape. Like if I took this, it would be like rotated around to become like a bullet. If I rotate it around this way, it will kind of be like a cone. It will be very wide out here and then kind of pointy here. So that's what you kind of need to think about. So if you're rotating it this way, you need y squared. If we're rotating it this way, we need x squared. So that's why you got to really read the question carefully, because it asks you to rotate it around the x-axis or the y-axis. So it makes a significant difference. Just like how it's very important, say I want to find the area bound between the y-axis or the x-axis. If it's doing the x-axis between 0 and 2, for instance, I'm finding the area underneath the curve. If I'm finding the area bound between the y-axis, I'm finding the area bound like that way, so this section. And again, I'll need to change the subject. If I wanted to find, going back to that question that I had up there, if I just wanted to find the bound between the x-axis, because we already got it, we got y. If I needed to find the area bound between the y-axis, I'll be integrating the square root of y. So I don't need x squared, I don't need x. That's the subject. Well, this is written here as volume. But say if I needed to find the area bound between the x-axis. So let's say I have y equals x cubed. Alright. If I wanted to find the area between like 0 and 3, x equals 0, x equals 3 in the x-axis, it would be. So if it's around the x-axis, I need y, which it already is, so it's be x cubed dx. The indicator is if it's x-axis, I need dx, therefore I need x within the which is y. But if I wanted to find around the y-axis, I'll need dy, meaning I need x by itself. Not x cubed, so I'm not going to do that. Then you do x equals the cube root of y. And then integrate that. Which obviously we then change to y to the power of 30. Blah blah blah.
So did you think of anything?
I'm trying to see something. I mean, other than the area of my segment.
Oh, yeah, can you explain how you make one with that?
Sure. So, I'm going to do a really big diagram. I'm not going to stuff that up. Yeah, I'm not going to do a big sector. I'm going to do a big circle. That was shocking, but that'll do. Minus segment. So the minor segment, we're talking about that. Okay? And the major segment is the other side, right? So what I would be told is the length of a radius from the center to the edge of that chord. So that's what's called a chord up there. Geez, that was nowhere near the center. There we go. Alright, so there's that chord and that segment is that bit out there, right? So what I want to do, we have a formula that helps you find the area of that sector. And we also have a formula that helps me find the area of that triangle. And then, so if I can find that blue area, sector, and if I can cut out the red area, the triangle, I'll get that black area, the minus segment. So the area, that blue area, going back to, was it 4 or something? We have area equals half r squared theta. Okay, this is in the formula sheet. Remembering that, of course, this is r, that's theta. Okay. That red area is the area of a non-right angle triangle is half AB sine C. Alright, where C is the angle and A and B are the sides of either side, which is half to half. Alright? So this would be half A is R, B is R, so half R squared sine theta. So therefore this area in there is that blue one, so half r squared theta minus half r squared sine theta, which we can then factorize to be half r squared theta minus sine theta. Again, you want to be working in radians when using this formula, because if you're in degrees, you might accidentally do 30 minus sine 30, which would be 30 minus a half, which is projected further. Yes, of course you can go. Nah, extension classes you can come and go whenever you need to. Like, it's totally fine. No, you don't need to worry about that. Oh, jeez. Never wait up. Like, if I'm halfway through explaining a question, just leave. It's all good.
No, I'm just gonna draw that in.
Might as well stop this video.